We're going to find a volume of a solid with base bounded by the graphs of the parabola y equals x squared and the line y equals 1, and with cross sections perpendicular to the y-axis, isosceles right triangles with hypotenuse on the base. So before we actually find the volume of this solid, let's briefly review isosceles right triangle. So an isosceles right triangle looks like this. It's a right triangle. This is the right angle here, and this is the hypotenuse. So because this is an isosceles triangle, the two legs have the same length, so let's call that A, and let's call the length of the hypotenuse B. So the area of this triangle is 1/2 A times A. This is 1/2 A squared. This is in terms of A. But also from Pythagorean theorem, A squared plus A squared equals B squared. So 2A squared is B squared, and A squared equals to 1/2 B squared. We can rewrite the area once again. The area in terms of length of a leg is 1/2 A squared, but since A squared is 1/2 B squared, this is 1/2 times 1/2 B squared, or 1/4 times the length of the hypotenuse squared. Now, to go to our solid, first we're going to do this in a series of steps. So first step, we want to sketch the base. The base is bounded by the graph of the parabola y equals x squared. So this is parabola, looks like this, and the line y equals to 1. The line cuts off the parabola right there, and this is our base. Now cross sections perpendicular to the y-axis. So we locate the y-axis and then select any y. Let y be here. This y represents any y between 0 and 1. Now sketch a line segment perpendicular to the y-axis through this point y. Now this, according to the problem, is the hypotenuse of the equilateral triangle. So now we sketch the other two sides. They look like this. This is the right angle, and let A of y represent the area of this triangle as a function of y. So then the volume is going to be the integral from 0 to 1 A of y dy. All we have to do is express the area of such equilateral triangle as a function of y. But note that this point here is the x coordinate on the right part of the parabola. So when our parabola is given by y equals x squared, we solve for x in terms of y. X equals to plus or minus the square root of y. So the right part of the parabola is x equal to square root of y, and the left part of the parabola, x is equal to minus the square root of y. So this distance from the y-axis to the right part of the parabola is the x coordinate on the parabola, which is equal to square root of y, and therefore the length of the hypotenuse is twice square root of y. So here's our triangle. It looks like this, and all we need to do is find the length of the hypotenuse as a function of y, and that is 2 square root of y. This is B right here when we discuss the isosceles right triangle. So the area A of y is equal to 1/4 times B squared. Now B in this case is 2 square root of y squared, and so once we simplify this, A of y is equal to 1/4 times 4 times y, which is just equal to y. and therefore the volume is equal to the integral from 0 to 1 y dy, which is 1/2 y squared evaluated from 0 to 1, and that's equal to 1/2. And that's the volume of the